Next, bond dissociation enthalpy. Bond dissociation enthalpy, BDE. So for example, let us take the hydrogen molecule. At STP conditions, hydrogen will exist in the gaseous state. Next, we know one molecule has one single bond. So therefore, if you take 1 mole of the molecules, they possess 1 mole of the covalent bonds. Therefore, bond dissociation enthalpy means energy required to break 1 mole of the bonds present in 1 mole of the gaseous state diatomic molecules is called bond dissociation enthalpy. Next, similarly, if you take the chlorine, 1 molecule has 1 bond, therefore 1 mole has 1 mole of the bonds. Therefore, if you take the oxygen, 1 molecule has 2 bonds, but 1 mole has 2 moles of the bonds. Therefore, bond dissociation enthalpy means energy required to break the 1 mole of the bonds present in 1 mole of the gaseous state diatomic molecules is called bond dissociation enthalpy. But if you take the oxygen, it is a diatomic molecule, it is in the gaseous state, but between 2 atoms double bond is present, 2 bonds are present. Therefore, if you take 1 mole of the oxygen molecules, now we have to break 2 moles of the bonds. Therefore, energy required to break all bonds present in 1 mole of the oxygen molecules is not bond dissociation enthalpy. It is not bond dissociation enthalpy, it is dissociation enthalpy of the molecules. Therefore, the difference between bond dissociation and dissociation enthalpy of the molecules is energy required to break all bonds present in 1 mole of the molecules is called dissociation enthalpy. Next, this is a diatomic molecule. Next, methane, it is a polyatomic molecule. Next, in case of polyatomic molecules, you see these are all identical bonds. So even though the bonds are identical, the bond dissociation enthalpies of the individual bonds need not be same. For example, for the breakage of this bond, if some amount of energy is required, for the breakage of another identical bond, definitely a different amount of energy will be required. Similarly, for the breakage of this bond, that means even though all bonds are identical, the bond energy required to break the similar bonds is always different. Whereas in case of the diatomic molecules, the bond energy, since only one molecule has only 1 bond, therefore we don't get any uncertainty about whether the bond energies changes or do not change. So, next, in case of the polyatomic molecules, since bond energy of the identical bonds are different, therefore usually we will use the word average bond dissociation enthalpy. Average bond dissociation enthalpy. The dissociation enthalpy. Therefore, average bond dissociation enthalpy, is equal to total energy required to dissociate 1 mole upon number of bonds present per molecule.